really. So we're going to take you on a bit of a journey around what we're doing and why we've done it the way we've done it. Some of you, depending on your background, some of you will sort of already know parts of the story. So it looks like we've got some clinical people. I can see some people, you know, Dr. such and such. So clinicians will probably understand a fair bit of, you know, what digital growth charts are and why, or what growth charts are and why we use them. Technical people will understand some of the technical parts already. So what we may find is that, you know, that for some of this, we're either patronizing you or bewildering you. We're trying to sort of cover all the bases really, because we're aware that we've got lots of people who are clinical, who are interested in what we're doing. And we've also got people who are technical, who are interested in implementing what we're doing. So we're trying to cover all the bases. Obviously, if we miss things or if things are not clear, then do ask questions. I think if we can get through the main part of the presentation, then we'll take a bunch of questions at that point. That would mean we'll get a good recording of the presentation, and that's something we can use as a, you know, future asset, as it were. We can share that with you. So I'm Dr. Marcus Baw. I'm actually a GP. I'm based in Yorkshire, and I'm a software developer and a clinical informatician. I have been involved in playing with digital growth charts for about 7 or 8 years since I started to try and implement some of the stuff in Ruby and Python and JavaScript myself, and then to be involved in.
I'll get my headphones.
I was approached to be involved in the Digital Growth Charts project last year by RCPCH. And over the last, so just less than a year, we have built a Digital Growth Charts API. So this is an application programming interface so that we can embed digital growth charts into future EHRs, electronic healthcare records. Simon, do you want to introduce yourself?
Yeah, hello, can you hear me? Yeah.
Yep.
Brilliant. So hi, I'm Simon. I'm a paediatrician. My background is in endocrinology, diabetes, adolescent health. I'm also I'm a coder. So I've also been sort of tinkering around with growth charts and so on for quite a long time. And the story is that back in April or so, I think it was, the Royal College was approached by the amazing people at the Red Book to see about making the Red Book kind of digital. And part of the Red Book, as you all know, those of you who've got children, that there are growth charts in there. And growth charts are quite complicated things. So the sort of first bit I wanted to talk about really was about what is a growth chart and where the idea comes from, and take it from there into sort of coding it. So the important thing also to take away from this talk is that all these people are involved here. So it's not just me and Marcus, but it's also sort of the wealth of experience in growth charts from the Royal College of Paediatrics and Child Health. All the people that developed the original paper charts, which you're probably more familiar with, those of you who have seen them. All the same people that developed those and all of the documentation that goes with them, like how to measure kids and so on, they're all working around the documentation on these charts and sort of supervising and overseeing what we're building. And also, as you can see, there's the RCPCH staff themselves as well. So all of the governance and all of that is very much part of this project. So what is a growth chart? And this is a picture of my back door, of my kitchen door, with my kids as they've been growing over the years. This is probably what we all do. Those of us that have got children, we tend to track their growth, don't we, and watch as they grow. And so a growth chart really is about describing what is normal, and therefore we can track, children's progress against what we know normal to be. And so describing normal involves obviously capturing numbers from lots and lots of different people. And why do we do it? Because growth is probably the most sensitive marker of children's health that there is. If kids are ill, they don't grow. And you will probably see it on the growth chart, possibly before you start seeing it in terms of symptoms and so on. And it's a good way not only of picking up illness, but it's also a way of tracking how successful your treatment is. So, if you've got a child, for example, with poorly controlled asthma, once you've treated their asthma successfully, you should therefore see their growth improve on the chart. So it's a really helpful measure, both of diagnosing illness, but also of tracking kind of interventions. And this is, oh, it's a shame. It shows you the first growth curve. So it was actually, first idea was back in the sort of 1700s, and the idea, it was this guy, Comte de Montbéliard, who tracked the growth of his own child. And it not only does it show growth, but it also shows speed of growth, what we call growth velocity. And growth velocity, people grow at different speeds at different ages. So it's kind of complicated. It's not like there's a uniform growth where everybody grows at the same rate from birth all the way up to childhood. You grow quicker at different patterns. So you're actually in a phase of growth deceleration from birth all the way down to about 3 years of age. Bottom was at about 5 centimeters a year up until early adolescence. And then you have your adolescent growth spurt where everything peaks up to about 20 centimeters a year, and then it bottoms down, slows right down to final height in your late teenage years. So kind of growth is complicated, and growth charts therefore have to capture that. If I can there. So, and I think I've sort of really talked about this, but you capture a population's growth, and you can use that to look at individual children. So the centile curves that you can see here, they describe a normal population. So centiles means as a percentage. This middle centile, the 50th centile, would describe half of the children in a population. So 50% would be on that line. The line below it is the 25th centile, so a quarter of children would be on that line, and so on. So that's how it sort of describes the population. There are 9 centiles, and these are each 2/3 of a standard deviation score. See if I can. In the old days, to build a chart, you used to have to gather loads of numbers of children. So this is like this is how you might have built it before. This is a set of 4,000 weights from children aged up to 1 to up to 21, and you can see they're all scattered in a sort of scatter plot to show you as per age as the weight changes over that time period. And in the past, you would have described that by drawing lines through it to set centiles, but you need quite a lot of children to be able to do this. And so what happened in the sort of 1980s was our statistician, Tim Cole, came up with a new method, which came to be known as the LMS method. And what he did was instead of drawing lines through the data, he broke it up into age chunks. So you can see the different colors here. Each one of these is an age band, and he therefore describes the distribution of data across each of these age bands. And for the way he does that is using the lambda, the mu, and the sigma. So these are 3 statistical kind of concepts which describe the distribution of data within that narrow age band. And you can therefore get an L, an M, and an S for each one of these age bands, and you can stitch them together and you get the whole age range. If you plot the L, M, and S, you get curves, and these curves are directly related to the centiles. And so you can end up effectively do stats that will link these 3 components together, and you'll end up therefore with a way of applying some maths to your LM and S, and you can end up with a centile or a standard deviation score. So the effect is that you need a lookup table. You have a lookup table which has age bands, and for each age band there's an LM and an S, and then for each child that your index child that you're measuring, you therefore compare them with your reference data. You might need to interpolate between values to get the correct measurement, the correct LM and S, and then you plug those into your equation, and you end up with a standard deviation score. So this is an example of the table. You've got sex and an age and an L and an M and an S. And so that's really fundamentally how the maths works. You use this lookup table to generate your standard deviation score or generate a centile. Now, the difficulty also is that there are a number of references involved here. So when you measure lots of children and stitch them together, we have the UK 90 reference, which goes from 23 weeks gestation, so preterm, all the way up to 20 years. But then in sort of the early 2000s, the WHO did a massive study, which was sort of multi-center across many centers, many countries. And they they used breastfed kids. And so the feeling was that the data that came out of that study was probably more accurate than our own UK 90, because that involved also bottle-fed kids. So what we did was what the growth chart reference group did was they took the UK 90 preterm data, and then they kind of slotted out the UK WHO data from 2 weeks up until 4 years, and they slotted that in. So we've got a number of references that are sort of stitched together. We've got preterm UK 90 goes into UK WHO, goes back into UK 90. So it's kind of complicated, and you have to have an understanding of all of this if you're going to build the charts electronically. So that's sort of why I'm going to this level of detail. And the LMS method is really popular. It's kind of the only way you would build a biological chart now. It doesn't just work for heights and weights. It works for really anything where you're trying to describe a standard of some sort of biological value. So it works for sitting height, for leg length. It could work for anything really. Peak flow. So sort of to bring it together, I'm going to sort of hand over to Marcus at this point, but the main thing is really to take away that growth charts are really complicated, and different EHRs, have their own plugins and so on. And I think it's really difficult to know how accurate they probably are. I've come to know over sort of trying to work on this over the last year. Actually, it's really difficult to get accurate numbers. I've been having, weekly meetings virtually with Tim, who developed this method in the first place. And there are all sorts of little areas and problems where you can make mistakes and you end up producing the wrong numbers. Right, Marcus.
Yeah, so I think Simon's done a really good job of explaining sort of how difficult it can be to create the growth charts in digital form, because you need to have the sort of clinical pediatric knowledge to know what it is you're doing and why. You need to understand the technical calculation in terms of like how you would program it. There's a statistical expertise of how you're getting the data from the LMS charts. And then there's actually also a kind of layer of health informatics if you're going to involve things like FHIR and SNOMED to make these kind of truly digital artifacts kind of thing. So that actually makes it sort of almost prohibitively expensive for EPR vendors to implement this kind of stuff. And although there are a few EPR vendors who have got this stuff, they are, in the end, it is not ever going to be enough for a few systems to have this in. We actually need this to start to become a ubiquitous expected feature inside most EPRs. So speaking as a GP, I know that both EMIS and TPP have implemented in their GP systems something that looks like a growth chart, but that's all it is. It looks like a growth chart in that it's an image, and when you enter a height and an age, it will plot the dot for you on the image. But what it won't do is ever calculate the centile for you, the SDS score. It won't do any of that automatically. So what I'm doing there is sort of illustrating that this stuff is, even for some of our big vendors, is beyond their reach in a way. So what we're trying to do is create a very simple system that takes all the complexity and wraps that in an application programming interface. So we're taking something that was very difficult and we're just wrapping it in a very easy layer. So essentially the Royal College of Paediatrics uses its kind of standard setting role, as it were, to take control of that complexity. We run a service which does that difficult calculation, and the consumers of that service can just send us things like height, weight, age, sex. They send that to the API and they get back the data that they need, which is, the centiles and things, and they can persist that in their system. So when we started off, I think in many people's minds was an app. What we need to do, the brief looks like, let's build an app that does growth charts. But of course, whilst that's kind of one way of approaching this, that doesn't make it ubiquitous across all EPRs. We've got to understand what is stopping growth charts ending up in systems. So we could have made a desktop application or a mobile app, or hard coded it into an EPR, worked with vendors to build it into their system and do all the maths on the EPR side. But of course that doesn't scale, because that just means that we would have to do that again and again and again with each of with each vendor, with each EPR, until we'd got these kind of things across all the systems. So the way that we've done it is to build an application programming interface. So this is a web service, an API. These kind of things form the infrastructural backbone of the web. And they are a standard way of allowing a computer to send information to another computer and get computable information back. So there are APIs for absolutely everything now. APIs for banking, telephony, APIs for maps, APIs for infrastructure. And I think that that's kind of what the APIs form, is a layer of infrastructure that a lot of people don't see. But when you, for example, if you ask Alexa for the weather, Alexa asks an API for the weather. So that Alexa will know your location and will send the location to a weather API and get back machine readable information that has weather data in it. And then it will choose the bit of weather data that it wants to tell you, which will be, you know, kind of readable English synopsis of the weather, rather than say the barometric pressure, and it will read that back to you. So invisibly, APIs are actually responsible for all of the cool stuff that we see in our world of connected digital cleverness, but it's under the hood. So that's why we wanted to build it as an API, because we feel that's the way to get this into systems. So electronic healthcare records would be able to consume our API, get the growth calculation done for them. So I've detailed some of the technologies and standards we've used. We chose to build the API in Python, but none of this is particularly critical for the consumer of the API, because the standard, the lingua franca, as it were, for accessing our API is to use something called REST, which is a technical acronym, which I won't bore you with. But essentially that means that it doesn't matter what the consuming system is using as its programming language or its basis. The consuming system could be an Android app or an iOS app, or it could be a desktop application, or it could be another server. It could be anything. And there is a standard way for it to consume our data. So we've used standards that exist already, things like OpenAPI 3.0. We've built a demo client in React for you, really, to explain how things work and for implementers to use as a kind of guide. So I'll show you the API. So I need to share my screen. So share my desktop. So I'm going to use a tool called Postman, which is essentially a testing tool for APIs. And I think it's important to say, I don't expect anybody to ever use the API via the Postman tool, apart from maybe developers who are implementing it. Postman's not good looking. What it is very helpful for understanding the kind of data that comes out of our API. But no end user would ever be using this. So no clinician should ever see this data in its raw form. But it's helpful to understand what the API actually delivers. So on the left is a payload of information which we're going to send to the API. So the API needs to know the birth date of the child, the observation date, the observation value. It needs to know the sex in order to know which table of data to look up on. And it can also do gestational age correction. So that's something that's actually quite complicated, or it's an additional complication. If you used a manual paper chart, you've got to think about gestational age correction, whereas our API will do that automatically for you. And it will actually do that now all the way through life as well. One of the reasons why gestational age correction used to terminate at 1 year or 2 years of age is purely just because it was complicated and irritating to have to do. Whereas because our system now does it without any extra thought, we can actually just continue the gestational age correction, because I think the project board, the clinical project board, has decided that it feels that that's actually a valuable thing to do right through life. And of course, as you get older, the difference that it makes is less and less and less as the two kind of tend together in terms of the the difference, but it's still something that the project board felt that now we had the technology to apply gestational age correction throughout life, and so therefore we should. So what I can do is I'm going to change a value here. So we'll make this 60, and I'll send that to the API, and the API will send back some information. So on the left, it's sent us back some of the things that we told the API, such as the birth date. It's worked out from the gestation the estimated date of delivery, and it's also worked out what we sent it, which was we sent a height of value 60. Now that's a pretty high height for this 32 weeker. So if I just go back to say 53 centimeters and ping that back, so that's in the normal range now. So what it's worked out here is the centile. So you saw how quick that was, and that was pretty much instantaneous to give us a centile for the measurement that I just worked out. So if we had 20 measurements over the life of a child, it would take pretty much the same amount of time to give us the centiles for all those 20 measurements, and we can also plot that on a chart, which I'll show you later. And so this is the data that comes back from the API. Now this is machine readable data. This is in a language called JSON, which technical people will understand, will have heard of. Clinical people don't need to worry about it, because obviously this is something that's under the hood. The great thing about it, though, is it's machine readable. So although as a human we can make sense of it, the idea is that no human really would be looking at this data. The computer would be picking out the bits it needs. So for example, it would pick out centile and 75 and say, right, well, so this is the 75th percentile, and we want to show that to the clinician in whatever way they want. So they might just want to see 70th percentile, or they might want that plotting on a chart, or more likely both of those things, so that they can develop a sort of good understanding of where the child is growth-wise. If I flick back to our demo, so this is a demo site that we've built just to show that working in action, and we've got a kind of zoomable, movable chart here. So I've put some values in just to show what happens when you put values in. So this is a demo site which we built in a JavaScript language framework called React, but there's no reason why anybody else would need to necessarily use React. This is just something we built it in because we had expertise in React. This frame here is coming from a library which we've also built in React. All of this work is open source. The server is open source, the client is open source, and this charting library is open source. And the idea is to provide you with a template, as it were, or something you can use for your own implementation. If you're building this into an EPR, we provide you with these dots. So each of those dots is a measurement like I've just shown you in Postman. It's returned information with the centile measurement, the SDS, all the things that a clinician would want to see. And we also have an API endpoint that will give you the construction lines for these parts of the graph. So you'll be aware that these graph lines are curved, and therefore you need data to be able to plot these graph lines in whatever language you're using. So if you're an APR vendor and you've got something that's built in Java, or you've built something in a web language, then it doesn't matter what technology you're using, there'll always be some way of drawing this graph. And then you draw the dots on it. And so in this case, we've got ages and we've got the heights and that sort of thing. If we flick across to the results page, you can see this is a synopsis. All this data was calculated by our API and sent back to the React client. We've got 45 centimeters, and we've got the centiles and that sort of thing. And you can see, as I went through, I increased the age of the child and increased the measurements, and we've got centiles on the second centile, 26 centile, 38 centile. This is all sort of silly synthetic data, but I can flick back to, if I make the child, let's make them another, move on a month, and we'll make them slightly taller, and we get another dot. So you can see how you can build this chart in real time. We don't persist any data on our API side, and we've made that very deliberate choice. It's a completely stateless API, which means that we don't keep any of this data because it's personally identifiable data. And of course, keeping data would have increased the complexity of our system by a couple of orders of magnitude. And actually, the natural home for all this data is in the EPR. So if you're using, let's say you're using a GP system, your GP system will already have all the demographic data about the child and all its the clinical narrative about the system, about their life and their vaccinations, and it will have their consultations. So that's also the natural place to store the raw data, so like the gestational age and the date of the measurements, the measurements themselves, so whether they're heights, lengths, occipitofrontal circumferences, so head circumferences, whether they are weights, and that would all be stored in your EPR, and then the EPR will consult our API to get the growth data, so to find out what centile it's on, and when that comes back, your EPR saves that locally in your EPR as well, so that then you've got a resource from which to calculate your charts, and you can persist that on the side of the EPR, which is where there is a legitimate legal basis for storing that data, and there is an information governance framework, and there is a data controller, etc., that governs storing that data on behalf of that child in your EPR. So that's kind of in a nutshell how it all works. We're aware that we've got a lot of people on the call. We've got a lot of different questions that might crop up, and different perspectives, I think, on what we've done. So we're keen to answer those questions and work with people. We're also aware this is it's early days, and this is an MVP product that we're showing you. So in some ways, as this evolves over the next few months, we can work with the suppliers that want to implement it to make sure that they've got the information they need to implement it, the help they need to implement it, and we can even get more hands-on and look at their code and their implementations and make sure that they are sort of accurate. I think one thing I would say about the open source aspect of the API is that we've deliberately built everything in open source, and that's really because we're a royal college and we believe in openness and transparency and the ability of all clinicians to be able to scrutinize our code for correctness. We're pretty sure it's correct. I mean, we've spent a lot of time testing it, but over time we would like feedback on the code itself, and to make sure that we've got it absolutely as right as it can possibly be, and that we are really expressing the absolute gold standard of height of child growth calculation. Although it is possible for somebody to take that open source code and run their own server, we absolutely don't recommend that. And the reason is that we are providing a service here, that the hosted version, the service that we provide as the college, is the warranted kind of service wrapped API that we provide, and it's only that we warrant to be correct. If you start running the server yourself, then you would be responsible for making sure that it's implemented correctly in your stack, and making sure that you've implemented everything so that the answers you get are right. And of course, you'd be responsible for registering it with the MHRA as a medical device, and you'd be responsible for DCB 0129 0160 registration. And so essentially there's a whole load of governance steps that you would have to do, whereas most of those governance steps reside with us if you use our service. So the idea is we're trying to increase the ubiquity of growth measurement by providing the service. We're not expecting people to run their own servers while that is possible. And, you know, we actually, you know, encourage people to test our service and make sure that it's right. So I'll pause for breath at that point. So I will, let's stop sharing and I'll go back to, so we can go back to the presentation, I think, Simon.
Oh, hang on. Yeah.
So, yeah, I'm just going to talk a little bit about the sort of context of what we're doing here, just in the wider sort of the big picture thing, which is that Royal Colleges are august professional groups that have been around for long periods of time. They're part of medicine. In certainly in the UK, we have Royal Colleges, but in other countries they have other comparable organisations. I think you've switched to the, presenter notes there. And these organisations set standards, and they are responsible for quality and safety. And they, in the UK, we have the Royal College of GPs, got the Royal College of Surgeons, Royal College of Paediatricians and Child Health, and these all disseminate best practice and guidance. And they've done that for years. Really, if you go back to the birth of each college, some of the colleges are hundreds of years old, some are quite recent, some have only come about in the last decade or so. In the origins of Royal Colleges, they would have always published this best practice as a document. So they would have had a journal article or original research or a synopsis of best practice, and that would have been a kind of printed booklet which you would get from your college. And then so that's what I call kind of Royal Colleges 1.0, was that kind of period. Then as the web became more popular, Royal Colleges started to use websites and digital formats like PDF to disseminate more digital guidance, but it was still textual. It was still a document, but it was just in a different form. Made it much easier to get hold of. So, you know, if you went to the Royal College's website and you click on the guidance tab, you could download the latest guidance about something in PDF in pretty much real time. So that's Royal College's 2.0. You know, they've moved forward to an internet era. And I see that, you know, what we might be on the cusp of here, and what I'm hoping we are, is Royal Colleges 3.0, which is where we can disseminate best practice and guidance as code or as a web service. So rather than a document where you know, a human would have to download the PDF and read it to understand what the best practice is, we could actually start moving to a world where that guidance becomes embodied in code, and colleges stand up their own web services so that an electronic patient record can send the right information to the web service and get the answer back of what the right thing to do in this circumstance. So we can actually see potentially a real interesting future of colleges starting to disseminate best practice as code. And that means that, you know, the huge and bewildering world of specialist guidance, which moves very fast and is really difficult to incorporate into an EPR because it's moving so fast and there's so much of it. If the Royal Colleges step up and start to serve some of this as a web service, then you can imagine that in 10, 15, 20 years time, every electronic patient record could have all the latest guidance kind of built into it, but no one that's building an electronic patient record would need to actually know and understand that guidance and implement it themselves for their EPR. They would always be referring out to a Royal College to get the right answer for that current patient. So in this case, we're using this to do growth charts, but there's no reason why we couldn't do it for diabetes management, or in the case of the Royal College of Surgeons, perioperative risk scoring, so that the Royal College of Surgeons would be able to send back an estimated risk for a specific patient in a specific circumstance having specific surgery, whether it's emergency or elective, and give the best possible tools to their clinicians for doing the job, really. And many of these things we are kind of doing already as clinicians, but we just don't have them in this kind of very easily accessible form in our EPRs. So, can I have the next slide, Simon?
Yeah.
I think I've probably already gone through some of this. So that's, you know, just illustrating that we think this is, you know, kind of pioneering work. We're the first Royal College that's got a web services. We're the first Royal College to have its own clinical code on GitHub. You know, we're sort of trailblazing this a little bit, but we're hoping that other colleges might follow suit. And of course, I'm a GP. So, you know, there are things that I'd like to see the GP college do. So maybe we'll see some of that in the future. What I'll do now, I'll just start going through the chat and just seeing what questions we have.
I've been trying to keep up as we go. I think there was a question about persisting data. So just to make it really clear, there are two ways you can do it. Your client can either send all the data on a child in one go, and that would, you know, if you sent 10 data points, that would represent 10 different calls. But you could then persist those results if you wanted, so that next time that, you know, request is made of the child, you've already got that data, so you don't need to make an API call. You only need to make an API call per data point. And in fact, there are 3 endpoints that we've got. There's one where you can request just results on the individual child per data point. You can also request the entire chart if you want. So if you were to send a request, you know, trisomy 21 height boys, it would send you back that chart, so that you could then plot one on top of the other if you wanted to render them that way. So we've tried to make it as usable as possible. If you've already got charts in your EPR, then you obviously don't need that data. You don't need to make that call.
Yeah, we've created an open source permissively licensed React charting library, which you can just actually use. If you've used React in your EPR, or if you want to kind of engineer our React client to work with just vanilla JavaScript, for example, you can just take the charting client and you can use that straight in your app as well. So that what we're trying to do is make this as frictionless as possible. So if you've got a web-based application, you can have good-looking charts with, you know, zoom and the points and the hover and all the nice things, pretty much straight away. One thing that we've actually taken an opportunity to do is to bring the sort of colorization of charts up to a sort of more 2021 view of things, as in, I think in the modern world, pink for girls and blue for boys probably isn't on message. So we've actually taken the opportunity to just go monochrome. And we've also come up with some sort of more wacky themes of sort of oranges and purples and things like that, for people to use if they want to, because, you know, pink and blue is probably gone out the window really a little bit, but all that's built into the chart client, you see. So that's something that people can just take and use.
Because it's in React, you can have props for all these individual things. So the charting library has got all of the data for the charts already in it, and it's also got loads of props for different things. So if you want to have different color centile lines, or different stroke or different stroke width, or you wanted to render you didn't want to render the grid lines, or you didn't want to render the axes, or you wanted the axes to be thicker or blue or whatever, all of these things are personalizable. And again, you know, it's all open source. So if people either, you know, want to contribute to the project, then really welcome. Just post issues, send pull requests, that kind of thing. We really would like to have lots of engagement, because the more people use it and personalize it to the way they want it, the better it is for everybody.
That's it. And I mean, we're aware that not everybody will be building their charts in React, so we had to pick something. If there are other types of consumer and you want help to implement charts, we should be able to help you with that. So we can work with your engineers to try and make sure that your charts look good. There's some questions about will this be free to access, and, you know, what are the cost implications. So it is, there is a free tier, which is limited to just, I think, 100 calls a month. And that's really just sort of so people can play around with it. We wanted to make sure that every hobbyist across the world, really, every paediatrician, or, you know, we know lots of clinicians who code like us, who would want to play with this and just, you know that they can check it and they can play around with it. So it is free to access. You can sign up at our developer portal right now, and you can get a free account, and you can send queries to the API and you'll get answers. Once you start moving up into a usage that's more than that, we are asking people to sort of join and enter into a commercial arrangement with the Royal College. And that's really because we want to make this financially sustainable. So this is not about making a lot of profit. This is about ensuring that the running costs are covered by the people who are consuming the API. So obviously this is providing a really neat feature to a lot of EPRs, and so in return for that free good, as it were, we'd like a contribution, and we're still coming up with the sort of exact details of how that commercial arrangement will sit. But the idea is that it's not going to be a vast amount of money, but the idea is that that represents a good contribution, and that means that the whole API project for the Royal College is sustainable, and that means that you know, going forward, our costs are covered. We have infrastructure costs and running the server. We have development costs in ensuring maintenance and updates and adding new features. And in particular, we don't see this as the end of the game. You know, we think that, I mean, first up, lots of people have asked us, great, you've got standard growth charts. Can we have specialist growth charts for Turner's, Down syndrome, achondroplasia? And yes, absolutely. They're the first things we've worked on, and they're actually in sort of like alpha at the moment, really adding those to the system. So they're not far away. But once we've done all the growth charts, what's next? So it would be things like blood pressure charts, or it might be pediatric early warning scores, and there's a whole range of things that we would want to potentially calculate, and we could move into, you know, emergency management of DKA, and there's a ton of things which we would like to see added. And of course, that for that to be fundable, you know, for that to be commercially viable and sustainable, we have to charge for the service. But as we say, you know, this is never going to break the bank, and the idea is that we want it to be sustainable for the implementers too. And you know, the college doesn't see this as a cash cow or profit making venture. This is much more about delivering best practice as code right into the EPR for our clinicians and for our clinicians' patients. So I'm just going to look through the questions. Peter Badger is asking, will it be hosted on HSCN? It isn't currently hosted on HSCN. It's just internet facing at the moment. I guess we could have an HSCN facing endpoint. There would be cost implications to that in getting HSCN connector. But if that was something that would make it more implementable, then yes, we could look into that. Is it compatible with Rio? Well, yes, it is. So Rio would need to implement it, but all they would need to implement is a call to a REST API, send us age, height, weight, age, sex, etc., and get back the data and show that to the clinician. So the burden for them of implementing this is way less than if they had to implement all the maths of calculating, which would actually be sort of prohibitively difficult, really. We've got a question about what have you done about the OFC discrepancy between UK 1990 UK WHO and the 1.4 standard deviation difference at age 4?
So we haven't done anything about that. That's just the data sets. So I can't change the data sets. They are what they are. There's still a step, you're quite right, between the different data sets. And that's just a function of, you know, how the project board have decided to use the UK WHO kind of interposed between the UK 90 data sets. I don't think I can change that unless we get a new one.
We can certainly, I mean, that's the kind of feedback that if you created an issue on GitHub about that, we'll put the link to our server where you could create that issue. We could take that back to the project board and say, you know, we've got clinical response here that says, you know, it's causing them a problem, that there is this step, and maybe we should be able to provide both the UK 90 and WHO data, but we wouldn't do that unless our project board felt that it was clinically safe and appropriate. So, but it's great to get this kind of clinical feedback, because we're sensitive to your problems that you're facing, the clinical coalface kind of thing, and you know, over time we will get a better understanding of what the growth charts currently are not doing for you, as it were, and we can try and address some of that in what we produce. So we really need T21, trisomy 21. Well, that's coming. We've already half implemented that. It's just in alpha at the moment. So specialist growth charts coming already. Well, 43 new messages. I'm going to start at the latest messages and work back, actually, because I think we've. So Peter's saying, if we render our own charts from your raw data, would the RCPCH want to approve the design? I think it would be helpful if we could see the charts. The project board have got clear views on how charts should be shown to clinicians. So what we've tried to do is build the React client as a kind of live documentation, as it were, of what the project board want it to look like. So where we've copied the look and feel of the paper charts as much as possible. And
just to say about that the project board have allocated resources to produce some documentation exactly on this issue. So how to produce charts. For example, the 50th centile has to be so-called de-emphasized. In the old charts, the big middle line was thick and heavy, the 50th centile, and that encouraged families to believe that all their kids should be on it and be disappointed if they were on other centiles. So it was de-emphasized. And you'll see that some of the lines are dotted and others are not. So there are guidelines that we're producing, which haven't changed really from the previous charts. It's really just to bring it into one place to help developers that are wanting to implement their own. And I'm hoping that our plugin, our TypeScript library, should kind of meet all of those. So also it's helpful to be able to see something, isn't it? Picture paints 1,000 words, as they say.
Yeah. We've also created a plugin for Google Sheets. So that allows, if you're a researcher, for example, and you've got 1,000 rows of children, whether they're, you know, research based or something like that, or whether it's 10,000 rows or 10 million rows, you can actually have you can use our plugin, which calls the API for each row and just gives you the data you want to an SDS or a centile, something like that. So for researchers, we've created a tool that allows them to easily access the API in their kind of native setup.
Yeah, it's really cool. It's on Google. It's on Google Sheets, so you can researchers that want to have their growth data and get SDS scores on it, they can put it in there, and then that makes an API call.
Will height velocity be possible?
Question.
Go on, Simon.
So not yet. So not yet is the answer, but I guess it will follow. One of the interesting things about growth charts, if you talk to Tim Cole, who kind of developed all of the LMS methods, he will tell you that ironically a growth chart is not really a growth chart, because for growth you need at least 2 data points. If you think about it, you need 2 data points for a velocity and you need 3 for acceleration. And of course, as I sort of said earlier, growth changes at different times in the life course. So, you know, it's faster at different ages. So you need standards for velocity as well. We have a velocity standard, but we don't have an acceleration one. And one of the interesting things Tim has actually published on in the past was this idea of thrive lines. So that particularly in weight, in the under ones, what's really interesting clinically for most, you know, for health visitors and midwives and paediatricians and GPs is that you want to know if a baby is losing weight or gaining weight too fast or too quickly. And by having a sort of a 5th centile, as it were, for weight loss or weight gain, that kind of, it stops, because at the moment you look at the numbers and as a clinician you have to make a judgment whether you're happy with the trajectory of the lines. It's very much how you feel. It's not quantified in any way. So the idea would be, I'm hoping, that once the API is in place, we can have clients not just sending us individual data points, but sending us an array of several. And then we can look at the standard deviation and we can say, well, is it drifting up? Is it drifting down? Is that acceptable at this age? Can we put a number on it? You know, is there a centile that this would be acceptable for, that kind of thing. So I think the opportunities for the future are really quite exciting once we've got this going. But at the moment, we're trying not to change too much practice. We want it to be very much what people are used to. We want them to have charts that they recognize. And then I think in time, actually centile charts have probably had their day, and we should be looking at things like standard deviation score charts, because actually you can have height and weight and head circumference all on the same chart that way. And you can look at, you can look at drift and all of those kinds of things. I think that's probably where the future lies, but step by step, I think.
That's it. We try to implement what people are doing now and make something that looks familiar to the average GP, the average clinician, rather than revolution. But what we were opening the door to revolution, definitely, because we could see a future in which, as Simon says, you could plot SDS rather than centiles, and it's by no means certain. What you will start to realize is that the paper charts were actually a type of paper calculator. You know, we plotted age and height, placed a dot, and then read off where the dot is in relation to the centile line. So it was forming a calculator for us. Now we don't need it to be a calculator because we're sat in front of a computer that can call the API and get the actual centile. So in that world, do we need curvy lines? Because the curvy lines actually make it very difficult to spot trends. They make it harder because the distance between the lines changes as you get older. So it makes it actually at the extreme left of the chart, a millimeter up or down is a much bigger deviation than on the right side of the chart, where a millimeter up or down is much less of a deviation. So what I'm hoping is that the research community and pediatric community will actually start to look at better ways of visualizing this. You know, we could actually get to the stage where, you know, we would have a tool that says, rather than this being a paper calculator, what is the best way of visualizing these trends so that you can detect a deviation out of the normal range sooner? Because it may be that actually, you know, using the paper charts, you have to have 6 dots and a gradual deviation before you can see a trend, whereas we might be able to find better ways of visualizing that so a clinician can see that after 3 dots. So yeah, and like Ray is feeding back, you know, in the chat, you know, you could have the same data, any number of views, you know, any kind of visualization of this, and that also allows different types of clinician to get different views. So I would imagine that, you know, there will be types of clinician for whom it's primarily data gathering on a population basis, and things like the National Child Measurement Project and, you know, health visitors, school nurses, mainly data gathering and elevating or escalating a problem with an individual child if needed. That's very different to the view that a specialist growth endocrinologist is going to need to see. So we should, you know, we can let the systems then evolve and provide all the views that are needed. Okay.
In a whole load of other stuff like bone ages and mid-parental height, you know, these are all kind of exciting things that we could add as time goes by. Yeah.
So that's been a really good chat. Thanks for all your questions. I've put a link in the chat as well to the, we've got a forum on a site called Open Health Hub, which is a place where we discuss open source health software. I've created a section in Open Health Hub just for the digital growth charts, so that really people can ask questions in there. We will also use it for frequently asked questions and almost like a blog site and that sort of thing. But please do ask your questions in there. The reason we want to answer questions in public is because then we only have to answer them once, and then we can point people to the previous answers. And so that's a bit more sort of scalable. It also, you know, means we've got a nice transparent project. So I've put the forum on there. I've put the digital growth charts server, which is open source code, and the developer portal where you can sign up and you can actually play with this in any language you want. I mean, our developer portal will actually give you snippets of code even for a variety of different languages if you want to try and play around with sending some queries to our API and getting some centiles back. So it's a really good start point. So I think, is the use limited to UK patients only? Well, no, not really. I think we've designed it with UK 90, so UK WHO charts in mind. So that does kind of limit it at the moment, but there's absolutely no reason why we wouldn't add other types of reference. So pure WHO, for example, or pure CDC, but of course, really the incentive for that would be if we had somebody coming along and saying we want to use it, and moreover we want to pay for it, then we could get on and develop that, no problem at all. So we're, in a way, we're being led by the community on this. We're being driven by the community. So if anyone's got any final, we've got 4 minutes left, so if anyone's got any final questions or comments, then I'm happy to take those. I'll give you a quick minute to pop your questions, but if not, then there's been a really valuable opportunity to sort of showcase what we're doing, and you know, we're hopeful that this is actually the start of something even bigger than growth, and it's, you know, tremendously exciting even within growth. But question there, are the current NHS centile calculators inaccurate?
Well, that's a good question. I think we have to assume they're accurate, but I think over the year, working very closely with Tim, I've come to realize how easy it is to make a mistake. And so, you know, I think it must be accurate because Tim was behind that. But some of the other packages, I mean, I don't know is the short answer. One of the simple things to do would just be to validate against our API. Though there may be some differences now, because also we're changing this age correction business. You know, we correct for gestational age up to 2 years if you're extremely preterm, but I think the project board have kind of decided we're going to carry on doing that. So that will mean there will be a small difference up to 3 months, you know, for any calculation for preterm babies, for example. So in that sense, I suppose it'll be different, but the current API as it works according to those old rules of, you know, correcting up to a year if you're over 32 weeks and 2 years under 32 weeks. So that at the moment we follow exactly the guidance as it stands, but I think the guidance is likely to change.
So we will evolve with the guidance. If this is something that you like the look of and you want to see it in your EPR, then I guess, you know, what we need you to do is go and see your CIO, your CCIO, your team that run the EPR in your organization in which you deliver care, and say, I want this implemented in my system. And if there's enough user pressure, then they'll come and see us, and we'll work with them to implement it in the EPR that you use. So hopefully